Two input NAND gate transistor work in different regions. Cutoff region, active region, act as amplifier, saturation region. Here we consider only two regions, cutoff and the saturation region. In active region, transistor act as an amplifier. So we don't consider this region since only need logic 1 or logic 0. If it cutoff circuit is open, if it's saturation, transistor will be closed circuit. Example, A is equal to 1, B is equal to 1, output of the AND gate as 1. 1 is the given to inverter NPN transistor is the high value given to inverter. So circuit will act as a closed or the short and VCC flows through ground and the output of the NAND becomes 0. For example, if output of the AND gate is 0, 0 is given as a input to the inverter, the circuit acts as a open and the output will be VCC drop access across R2. So use the logic 1. Transistor logic TTL, also known as the CTM or the TL2L family, because in this we are only depending on the transistors to perform logic operations. BJTs are used NPN, most popular logic family. TTL uses the transistor operating in the saturated mode. Advantages: good speed, low manufacturing cost, wide range of circuits, and availability of the SSI and the MS2. SSI is the code will be less than 100 and a small scale integration. MSI in the 100 to 1000 medium scale integration depends on a number of transistors integrated in the circuit. Demerits: high power consumption, moderate packing, and density, generation of noise spikes. Subfamilies: standard TTL, high speed TTL, scores, short, short, Schottky TTL, low power Schottky TTL, advanced low power Schottky TTL. Two input TTL NAND gate consists of 4 transistors Q1, Q2, Q3, Q4, 3 diodes D1, D2, D3, 4 resistors R1, R2, R3 and R4. Q1 is a multiple emitter transistor. 2 emitters with emitter will be the input, and Q2 acts as the phase splitter. Q4 is the totem pole arrangement. D1, D2 are the connected to the two input diodes or the emitter of the Q1. Basically, this is for the avoiding negative spikes of the voltages. The input is the when a negative spike appears at a input terminal, it is a negative spike. Diode will be conduct and bypass this spike to ground. So D1 and D2 is mainly for avoiding the damage of the Q1 from the negative spikes of the voltage at input terminals. Diode D1 placed between Q3 and Q4. Diode D ensures that Q1 and Q4 are not conducting simultaneously. So also the Q3 will act as a emitter follower. Working case 1, when the both A and B are 5 volt or the high voltage, for the both inputs the emitter base junctions will be in the reverse bias, and so no current flows through the emitter of the Q1 but at the same time the collector base junction Q1 will be forward and biased, and the current will be flowing through R1 from VCC to the base of the Q2, making Q2 turn on. When Q2 is on, the current will flow through emitter of the Q2 and the base of the Q4 and makes Q4 turn on. When Q2 is on, the current will flow through emitter of the Q2, base of the Q4 and makes Q4 turn on. The collector current Q2 will be follow and through the R2 and it will be produce some drop across it, hereby reducing the voltage at the collector of the Q2. So here's the voltage is reduced. This makes the Q3 off. Q3 off, input 1 1, the Q4 on, and then output 0, which makes the output V0 at 0 volt. Case 2, either A or B is low. If any one input is low, the corresponding emitter base junction will be forward biased and the emitter collector junction will be reverse biased. Current flows to the ground through the emitter of the Q1 so that Q2 will be off. So Q2 is not able to allow current to flow, making Q4 also off. So Q3 will be on since it will be get enough current to base device from the collector of the Q2. Now AVCC will flow through Q3. D gives a high output 1. So output voltage VCC drop across the resistor and the transistor diode. V is equal to VCC minus VD minus VR2 minus VQ3.